Hello friends, this is Rashmi Singh. Welcome to my channel Unraveling Science. Solutions for Magnetic Effects of Electric Current, Class 10, Chapter 12, Part 1. In-text questions. Why does a compass needle gets deflected when you brought near a bar magnet? The needle of the compass is a small magnet. That's why when the compass needle is brought near the bar magnet, its magnetic field interact with that of the bar magnet. Hence the compass needle gets deflected. Draw the magnetic field lines around a bar magnet. You can see the diagram here. List the properties of magnetic lines of force. The properties of magnetic lines of forces are: first, outside the magnet, the field lines are directed from north pole of the magnet towards the south pole. Inside the magnet field lines are directed from south pole to north pole. Magnetic field lines do not intersect each other. Magnetic field lines are closed curves. Relative strength of the magnetic field lines is given by the degree of closeness of these lines. Why don't two magnetic lines of force intersect each other? The two magnetic field lines do not intersect each other because if they do, it means at the point of intersection, the compass needle is showing two different directions, which is not possible. Consider a circular loop of wire lying in the plane of the table. Let the current pass through the loop clockwise. Apply the right hand rule to find out the direction of magnetic field inside and outside the loop. As you can see here, for the downward direction of the current, the direction of magnetic field will be as if emerging from the table outside the loop and merging with the table inside the loop. Similarly, for the current flowing in an upward direction, the direction of the magnetic field will be as if emerging from the table outside the loop and merging with the table inside the loop as shown in the figure. The magnetic field lines in the given region is uniform. Draw a diagram to represent it. You can see the diagram here. The magnetic field line inside along a straight solenoid carrying current is A0. B decreases as we move towards its end. C increases as we move towards its end. D is same at all points. The correct answer is D, same at all points. Which of the following properties of the proton can change while it moves freely in the magnetic field? There may be more than one correct answer. A. Mass, B. Speed, C. Velocity, and D. Momentum. Option C and D are the correct answers. When the proton enters the region of magnetic field, it experiences a magnetic force. Due to this, the path of the proton becomes circular. As the result, the velocity and the momentum change. In activity 13.7, how do we think the displacement of the rod will be affected if current in the rod AB is increased? If the current in the rod is increased, force exerted on the conductor increases, so the displacement of the rod increases. A stronger horseshoe magnet is used. If a stronger horseshoe magnet is used, the magnitude of the magnetic field increases. This increases the force exerted on the rod and the displacement of the rod. Length of rod AB is increased. When the length of rod AB is increased, force exerted on the conductor increases, so the displacement of rod also increases. A positively charged alpha particles projected towards west is deflected towards north by the magnetic field. The direction of magnetic field is A towards south, B towards east, C downwards, D upwards. The correct answer is D upwards. The direction of the magnetic field can be determined using Fleming's left-hand rule, as you can see here in the picture. Since direction of the positively charged particles is towards the west, direction of current will also be towards the west. The direction of magnetic force is towards the north, hence the direction of magnetic field will be upward according to the Fleming's left-hand rule. State Fleming's left-hand rule. As you can see here, Fleming's left-hand rule states that if we arrange the thumb, central finger and the forefingers of the left hand at right angles to each other, then the thumb points towards the direction of the magnetic force, center finger gives the direction of the current and forefinger points in the direction of magnetic field. What is the principle of electric motor? The principle of electric motor is based on the magnetic effect of the current. A current carrying conductor, when placed in the magnetic field, experiences force and rotates. The direction of the rotation of the conductor can be determined by Fleming's left-hand rule. What is the role of the split ring in the electric motor? The split ring in the electric motor, also known as commutator, reverses the direction of the current flowing through the coil after every half rotation. Due to this, the coil continues to rotate in the same direction. Explain different ways to induce current in the coil. Different ways to induce current in the coil are: first, by moving a magnet towards or away from the coil or vice versa. Second, changing current in the neighboring coil. State the principle of electric generator. An electric generator works on the principle of magnetic induction. In the generator, electricity is generated by rotating a coil in the magnetic field. Name some sources of direct current. Some sources of direct current are cell, DC generator, etc. Which source produce alternating current? AC generators, power plants, etc. produce alternating current. A rectangular coil of copper wire is rotated in the magnetic field. The direction of the induced current changes once in each: A 2 revolution, B 1 revolution, C half revolution, or D 1/4 revolution. The correct answer is C half revolution. Name two safety measures commonly used in electric circuit and appliances. The safety measures commonly used in electric circuits are: first, fuse, and second, earthing. Fuse. Each circuit should be connected to a fuse because a fuse prevents the flow of excessive current through the circuit. When the current in the circuit exceeds the maximum limit of the fuse element, the fuse melts to stop the flow of the current, protecting the appliances connected to the circuit. Earthing. Earthing protects the user from electric shocks. Any leakage of current in an appliance is transferred to the ground by earthing, and the people using the appliances are prevented from getting electrocuted. An electric oven of 2 kV power rating is operated in the domestic electric circuit of 220 volt that has a current rating of 5 ampere. What result do you expect? Explain. Now, current drawn by the electric oven can be obtained by the expression P is equals to V into I. So we know that power is 2 kV, so that is will be 2000 watts. Voltage is 220 volts. So current will be power upon V. That will be 2000 upon 220, that is 9.09 ampere. The current drawn by the electric oven is 9.09 ampere, which exceeds the safe limit of the circuit, that is 5 ampere here. This causes the fuse to melt and break the circuit. Which precautions should be taken to avoid the overloading of domestic electric circuits? The precautions that should be taken to avoid the overloading of domestic circuits are: first, too many appliances should not be connected to a single socket. Second, too many appliances should not be used at the same time. Third, faulty appliances should not be connected in the circuit. Fourth, fuse should be connected in the circuit. Thanks for watching. Please do like, share and subscribe.